Okay, nice to meet you all. JP Layer. I'm a solution architect at AWS. I've been there for a year. Actually, it was a year yesterday. So I'm still fairly new in AWS. And before that, I've been a principal architect at GE Healthcare, working on their PACS and VNS solution for the past 10 years. So the way you can run MONAI Deploy on AWS today is by two different services. You can run that on top of EC2, or you can run that on top of Amazon SageMaker. There are different approaches or different, let's say, manner to run this MONAI Deploy logic on top of AWS. And the way you do that in EC2 is not quite the same way as the way you do that in SageMaker. So if you do that in EC2, you are going to run a virtual machine with the proper operating system, for instance, Ubuntu 20 or 22.04. And then you are going to deploy the MONAI Deploy packages on top of that, which will give you the MONAI Informatic Gateway, MONAI Workflow Manager, Task Manager, and the other components. And then you will be able to configure and deploy your maps in it. And then whenever you need to do some inferencing, you will be pushing DICOM data into the MONAI Informatic Gateway. And the logic will be so that the map will be selected and the prediction result will be generated. If you do that in SageMaker, it's a bit different. And as Vikash and the other intervenant have explained already, you will be using only the map. So we have a way to actually use the SageMaker framework itself to load the map into it. And from there, you will be using the SageMaker infrastructure to invoke the map and get the prediction result. So we'll cover that a bit deeply in the slide. And then I would also like to introduce during that presentation our new service called Healthlake Imaging. That is a service that we did announce lately last year. This is a service to actually store medical imaging into the cloud. It's the real focus of that service. It only does that. Right now, it only focuses at DICOM, but moving on, it should be able to actually acquire other type of medical imaging, think about pathologies or ophthalmologies, these kind of standards which are, as of today, outside of the DICOM standard. So whether you run your MONAI Deploy infrastructure on EC2 or in SageMaker, you are still going to consume what we call EC2 instances behind the hood. So we have a different type of EC2 instances in AWS. And then we have two main families of EC2 instances, which are GPU-backed. These are virtual machines which have access to CUDA-compatible GPUs, so NVIDIA. And then, as you can see there in that table, they have different type of CPU count and RAM count, along with instance store storage. So the instance store storage is not to be confused with your normal file system where you will be putting your operating system and your application. This is an ephemeral storage attached to the virtual machine for you to use as a cache. So I guess Ben sooner this morning was explaining about the persistent cache and the different cache available in MONAI. This will be the perfect place to actually locate the cache because that type of storage is way faster than an SSD. So if you want to have an exhaustive list of these EC2 instances available to you, I have the link there. I will make sure that that presentation is shared with you. And then that will actually lead you to the AWS webpage for the different instance type. I have only listed there the instances which are both compatible with EC2 and SageMaker and are running into x86-64 Intel architecture. We also have other GPU-backed instances, which are based on our Graviton CPU, which are ARM-based CPUs. So that is an example of how you would be running a map, MONAI application package, inside of SageMaker using the asynchronous inference endpoint. So SageMaker has the ability to actually spin up for you the inference endpoint based on a model that you have created inside SageMaker or even outside of SageMaker. So should have you use another tool to create your model and to train that model, you could actually still import that in SageMaker and create the endpoint in SageMaker framework so that that endpoint is made available for your production workloads or research workloads. So the way it works is that you would have to actually put your input data into an S3 bucket location, and then you will be invoking the asynchronous endpoint itself. So that's an HTTPS endpoint that you invoke. So the endpoint will be looking into the S3 bucket for the inputs, will be processing the output results, and then will be placing the prediction results into the S3 bucket as well. When the prediction is finished, then the SageMaker framework will take advantage of the SNS service in AWS. That's the notification service. And then you can actually integrate with that SNS service to tell that the processing of the inference is finished, and then you can go gather the result on the S3 bucket. What we can do as well for SageMaker is actually taking advantage of auto-scaling. So this is the concept of you configuring a model and an endpoint in a way that if there is a lot of people hitting the endpoint because you have a lot of concurrent requests for that inferencing to happen, then the system can scale automatically and make sure that all the requests are honored in a timely manner. This is quite interesting because what that does for you is making sure that you only consume the amount of resources that you need at a certain point in time. And when that, let's say, workload is over because you are reaching a time in the day where people are not using that endpoint anymore, then the system will shrink automatically the amount of resources made available to the endpoint so that you are not being charged for resources that you will not be using. For instance, during the night, it's possible that less people are going to use that endpoint. Then what would you be paying for these resources that you are not using? With the auto scaling feature, the system makes sure that you are only being charged and only being charged for what you consume, really. So you will see during the demonstration that we made an integration both for MONAI Deploy on EC2 and MONAI Deploy on SageMaker with our new service called Amazon Healthlake Imaging. That means that the DICOM data that we are going to process is not stored in the MONAI Deploy server itself. It's not sent to the MONAI Informatic Gateway. It's directly picked up from the Healthlake Imaging data repository. So I will explain you briefly what is Healthlake Imaging, how it works, and then I'm sure that for the demonstration, it will help you to understand the workflow. So Healthlake Imaging is a service which consumes DICOM data from an S3 bucket. What that means is that for a start of that workflow, the DICOM data needs to be copied onto an S3 bucket. Then Healthlake Imaging can actually be invoked to import the data found on the S3 bucket in a specific prefix, and then it will do multiple things with that data. It will take the pixels and whatever the compression type of the images in the DICOM data is, it will convert that into a file format called HTJ2K. So this is an alternative to JPEG 2000, which provides with the same compression ratio, but has the advantage of being way less consuming in terms of resources when it comes to the decoding of the images. HTJ2K, just like JPEG 2000, comes with a nice feature, which is the progressive decoding. What that means is that the data inside of the file is organized in such a way that even if you don't have the complete file, let's say that you have only downloaded a fourth of the JPEG image, then you are still able to reconstitute a complete image with lesser resolution. And that can be of advantage if you actually have the need to work on lower resolution images. And I guess that might be the case in machine learning for medical imaging, actually. So that gives you the ability to speed up your workflows by not necessarily downloading the entire dataset, but only maybe the first few kilobytes of every single DICOM object, or let's say pixel data for the DICOM object. And then with that, you will have sufficient enough information to start training your model on top of. So there I do the distinction between the image and the DICOM object itself, because Healthlake Imaging actually decomposes the DICOM object into parts. It stores the header into a specific metadata that it's creating on the fly. And then it stores the pixels of each DICOM object into that new HTJ2K pixel raster. And so the API of Healthlake Imaging gives you the ability to request the metadata or to request the pixel data. As I said, the service was announced lately last year. It's not globally available yet. It's still in preview release right now. Moving on, you will also have the ability to request the entire DICOM object, just as you did ingest it into Healthlake Imaging. But at that point, you can only request back your data by requesting the metadata and then requesting the pixels data into different steps. So we have designed Healthlake Imaging with the idea that we should be able to actually reduce the amount of copy for the DICOM studies that are happening today in the production environment. A lot of hospitals or institutions today have a first copy that they use for production. They will have a second copy that they will use as a backup. And over time, they may actually have even a third copy that they did store on a warm storage, or maybe they did export to the cloud. And now they have that third copy that they are paying for because they still need to maintain it. But it's not really useful for the daily production. It's just a kind of a, protection for them. So when you actually use software vendors for medical imaging systems, such as, a PACS or a VNA, oftentimes these applications are going to store the data on different storage, and the storage will be on-prem. That could be a NAS, that could be a SAN, could be a warm storage, whatever the application can integrate with. But that storage is not necessarily safe and sound because it's on premises. And even if you do manage to protect it from cybersecurity, you can barely make sure that it will always be protected by, environmental disasters. So these people are going to try to create a second copy of the data onto another data center, onto another storage. And this is infrastructural cost that they need to sustain. Instead, with Healthlake Imaging, you have the ability to move your DICOM data onto the cloud, and you can be relieved of the burden of making sure that you have a second copy of the data because we, AWS, take care of that for you. We make sure that the data will be always available. We are also focusing the service for fast image access. So in medical imaging, in production medical imaging, we have that, let's say, business SLA, or let's say industry SLA, which is you should be able to provide by the images to the user in less than 2 seconds. With Healthlake Imaging, we are right now at the subsequent image access time. What that means is that if you hit the API call to actually get the pixel rasters back, you will generally be served in less than a second to get the full image downloaded on your client. We have automated infrastructure management. Indeed, this is a managed service in AWS. What that means is that you just need to create the data store for Healthlake Imaging into your AWS account, and the rest is taken care of. The rest being, you don't have to think about how much storage you need to allocate to. It's going to be allocated automatically. You don't have to think about how much endpoint you need to allocate to have a proper response time. The system is going to scale in terms of performance automatically as well. And then finally, we are working with a lot of ISVs, software developers like Intel Rad or like NVIDIA for that matter, who are working on integrating their system with Healthlake Imaging so that the integration with the production PACS and VN environments on-prem can be seamless. So today you have a few of these software vendors already who are supporting different storage technologies such as S3. But S3 is a commodity storage type. It's not necessarily specialized into storing medical imaging, whereas Healthlake Imaging is really focusing at that. So we expect that with these partners investing engineering effort into integrating into Healthlake Imaging, overall it's going to provide for better patient care with faster image access and also more reliability of the images. I'll pass on that one. This is briefly how Healthlake Imaging is built internally. So it does rely on S3, EC2, and DynamoDB that you as a consumer of Healthlake Imaging don't get to see. These are services that our engineering team is implementing on top of the Healthlake Imaging framework to render the service. Yeah, something to mention still. We are really designing Healthlake Imaging as a service which will be leveraged by software builders. So as I said already, PACS or VNA software developers company will certainly take advantage of that, but not only. We're also designing the service such that it's fairly easy for researchers or data scientists to take advantage of the data and be able to run analytics or machine learning on top of it. So like I said, we are actually focusing that for enterprise imaging, AI/ML, and then long-term archiving. So just like you could have different tiers in S3 where the data trickles down the different tiers to be as less expensive to sustain, or let's say to keep as it gets older. Healthlake Imaging will have the same concept where data which has been stored for a while into Healthlake Imaging will actually be less money consuming than the more recent data. And then, yeah, to finish, Healthlake Imaging is actually complementing the different sets of healthcare and life science services that we had already. We had Healthlake Analytics, which is, to oversimplify it, which is a file server, a file repository where you can create the longitudinal view for a patient, and then you can get access to different, let's say, factors about the patient, procedures, and let's say stay into an organization. And then we have Amazon Comprehend Medical already, which is used for natural language processing. So now with the addition of Healthlake Imaging, we now have the facet where people will be able to run analytics and machine learning on the medical imaging for this patient as well. So right now the service is in preview. What that means is that if you go onto your AWS console on your account, you are not going to find Healthlake Imaging. There won't be an icon for that, and there won't be a link to access to the console. In fact, there is no console as of today. Healthlake Imaging is being accessed via the API or via the AWS CLI. That being said, if you're interested in giving it a try, you could scan that QR code, and that's going to lead you to the registration page where you can register to get your account enabled for Healthlake Imaging. I want to emphasize that as of today, the service is only available into the US East 1 region. So this is the region in Virginia, United States. You would still be able to use it if you are not doing your daily work in AWS Virginia region, but performance and reactivity may vary if you are very far away from that region, just so you know. All right, so now back to implementing MONAI Deploy on top of AWS. So on that diagram, you have actually a simple representation of what we did for the demonstration. So there on the left, you have a web application which is entirely built on AWS serverless services. What that means is that you can actually build a complete web application, something which resembles a PAX or a VNA, as you will see during the demo, without to have the need to run a single operating system yourself. What that gives you is the ability to actually have your application entirely managed by AWS. Things like the storage you use, the database you use, you don't have to think about how to operate them. The database is going back automatically, it will scale automatically, so will the storage, and so will the, let's say, compute that you are using. So that's one of the advantages that you can gain in developing software on top of AWS. So in that example, you have the web application there, which will interact with an EC2 instance, which contains MONAI Deploy Express. And then the data will be actually fetched from Healthlake Imaging. So I'll show that to you right now. So we build that application. Again, I want to emphasize that there is no user interface for Healthlake Imaging as of today into the AWS console. So based on what is available in the API, we built our own for the purpose of that demonstration. So there you can see you have a data store, and in Healthlake Imaging, everything starts with a data store. Think about the data store as a container for your DICOM data. You create that container, and then all the operation that you want to do with Healthlake Imaging will assume that you provide a data store ID as a parameter. So now if you want to import a DICOM study into a specific data store, then you provide the location on the S3 bucket for the data, and then you provide the data store ID that you want the data to be imported in. So we have already imported a few studies for the purpose of the demo. So there you can see we have one MG study, one CT study, and then two CT studies with segmentation. There you could actually go there in the MONAI data store, and this would give you the list of imports which were done. So I've made some import into it yesterday to create the studies that we're going to use for the demonstration. So now if I go into the DICOM data menu, I can see the studies which were imported into that data store, the MONAI data store. And then from there, if I wanted to, I could actually display the images as well from the data store right away. So that right now is a version of OIF, which is integrated with Healthlake Imaging. And then we can access to the data just like that. So we can also request an inferencing to MONAI Deploy Express. So there I'm opening a breast study. And then we have that menu there, which is integrated with MONAI Deploy Express. So on that specific study, I can actually request the breast density classification. And if I click on that button, oh, hold on. Going to refresh that. Okay, looks like my browser crashed. That's demonstration effect. That's fine. Let's try again. Okay, so let's take the breast density study again. Then I'll try to call the inferencing. Okay, so now it's running. So what's going on right now is basically the web application that you have seen there has some backend services, some business logic happening in the backend. And that business logic has notified the MONAI Deploy server that we wanted to inference that specific study with the breast density classification algorithm. So it's going to take a few seconds to get back to us, and I'm going to take advantage of that time to show you what's going on in the backend actually. So that gray box there is the application that you have just seen. And when I clicked on that run button for the breast density classification algorithm, that did put a message into a service in AWS that we call SQS. This is our messaging queue system. And then we have there the HLI to MONAI plugin, Healthlake Imaging to MONAI plugin. That plugin is installed onto the MONAI Deploy server itself. That plugin is actually listening to the queue, and it will receive the message that that application has published for it. In the message, you will find the identifier of the study in Healthlake Imaging, along with the data store for the Healthlake Imaging container that we're interested in. And then you will also find an identifier that we call the workflow ID for the inference that we want to run on. So MONAI Deploy and MONAI Deploy Express, for that matter, have different ways to run. You could actually send the data into MONAI Deploy, and based on the dichometer, MONAI Deploy will be able to figure by itself which workflow is the best to run on that data. Or you could actually instruct MONAI Deploy to run a specific workflow if you want to. So in that case, in the user interface, when I did select the breast density classification algorithm, I did basically tell to the plugin that that's the one workflow we want to run. So now the plugin is going to go fetch the data from Healthlake Imaging and then put the data onto a place where MONAI Deploy can consume it. And then it will send a message to Workflow Manager to tell, hey, the data is there. And by the way, that's the workflow I want you to run. Workflow Manager is going to actually trigger the task manager, which itself is going to invoke the map, the breast density classification map. And so maps are different. They don't necessarily all output the same thing. In that case, the breast density classification algorithm does not output DICOM data. So we are going to take a different path where the prediction result is going to be stored on the MONAI storage. And from there, the plugin will be able to find the prediction results. And then we'll actually convert that into something that our application can consume on our own S3 artifact bucket. So the data will flow from the map into the MONAI storage. The plugin will take it from the MONAI storage, and the plugin will move the results into our own S3 store. At that time, the inferencing should be finished. Yeah, so you see it's finished now. I did increase the size of that window, so it's looking a bit weird like that. Okay, so as you can see now, we have a node which was not there before, and that node contained the result for the breast density classification. So as Vikesh explained a few minutes ago, you have this 4 type of breast density, A, B, C, D. And then for that study, it seems like the patient was more of a type B because this is the highest probability that we have returned there. We could do other thing with the result as well. So in that case, I could actually download the result from the application, and I get my result there. And well, I can see right now that result contains the densities. So I'm getting the same thing as the one I have in the user interface. That being said, if I was to use other algorithm with the same workflow, other algorithm who can actually produce something else than just text, I should be able to display them as well. So if I go on to that study, for instance, and I did run the inference for that one before the demonstration, because it takes a bit longer for that one because the segmentation is created. I didn't want you to have to wait for 2 or 3 minutes in front of a screen which does nothing. So I did run that one sooner this morning, and then as you can see, the inference did return a segmentation to us, which was attached to the study. And then it also did render an STL, a stereolithography file, a 3D, which constitutes your mask for your label, for instance. And then I could also download the DICOM file, the DICOM segmentation directly, and then use it. So I want to emphasize that all of that software that you are seeing right now and the infrastructure which runs the MONAI Deploy Express, all of that I could do without any knowledge of machine learning. I'm not a data scientist. I know pretty much nothing in machine learning, and in particular for medical imaging. But the concept of MONAI Deploy Express and the map itself make it so easy for people to reuse that even a software architect or an IT engineer just like me who doesn't necessarily have specialized knowledge in that line of business can still take advantage of it. So that's one way to do it with EC2. So in that case, MONAI Deploy Express was deployed on EC2. We have other ways to do that as well with SageMaker. So that's the same application there because you could actually integrate that SageMaker endpoint with whatever you want. But then the concept is a bit different. In that case, what we do is that we will be running the map directly into SageMaker, into a container managed by SageMaker itself. So the map that we are going to use is a map available on MONAI repository. That's the spleen map. And we made a small modification for that map to actually be able to fetch data from Healthlake Imaging. So the map by default will not do that. You would expect the data to be into a local folder of the container called input. But thanks to the logic of, let's say, thanks to the design of having different operators and data loaders available in the map, we were able to create our own data loader, which can easily integrate with Healthlake Imaging, fetch the data from Healthlake Imaging into the memory of the map, and then the inferencing can happen from there. So I will go log on to my AWS account and then show to you what can be done with that as well. So this is the SageMaker environment. And then just like you have been using, I believe, Google Colab this morning, where you could actually have something very similar to a Jupyter notebook, or in fact, having a Jupyter notebook, you can have the same concept with SageMaker. So SageMaker basically allows you to develop, train your models, but also to run them in production. So I'll select the MONAI notebook, and then that's the one. Okay, so now I'm in my Jupyter Notebook environment within SageMaker Studio. And this is actually a workshop that we have made available on GitHub as well. I will provide you with the link later in that presentation. And what that notebook does is basically taking a map which was created outside of SageMaker and then configuring SageMaker so that the map is made available via an endpoint. And then that endpoint can be invoked so that the processing of your DICOM data is actually turned into prediction results. So really briefly about what that does, this is us invoking the SageMaker client and Boto3 clients with Python. This is Boto3 is actually the, let's say, SDK for Python to interact with the AWS services. So you can actually create some object to interact with S3 and then interact with SageMaker as well. So this is us doing that there. And then at that step there, we are actually taking the model for the spleen segmentation and then preparing the model to be, let's say, embedded into a SageMaker container. Okay, so at that point, the SageMaker container, well, let's say the model itself is ready. And then that step where we create the model object is basically us telling SageMaker that we want to take that specific model and we want to embed that into a SageMaker container. So there we can see a few information such as the instance type. So we spoke about the instance type a bit sooner in the presentation. G4DN 2x large will basically give you the amount of CPU and RAM attached to that specific instance, which is going to run the model. You will notice that there is an ML there in front of it. That's because this is going to be the same hardware profile as a normal G4DN instance, 2x large in that case. But then the ML instance will come with some specific file system, which is already prepared to run machine learning software. So you will find different, for instance, Python install and PyTorch install on it, all these kind of things. You don't have to do it yourself. It's built in that specific image for you. Then when you have actually specified your model, then you can actually create an endpoint configuration. And when you have created the endpoint, well, the endpoint configuration at least, then you will be able to create the endpoint itself. I'm not going to do that right now because it takes a while to create an endpoint. It can take a few minutes to invoke the endpoint the first time. So I did that ahead of time, but what that gives you in SageMaker is if I go into the inference menu, then we can see the model which was created with the code I showed you just before. We can see the endpoint configuration, which basically links the endpoint to the model. And then we can see the endpoint itself. And that endpoint, yeah, there you can see it will be using an MLG4DN 2x large instances when it's invoked. And then that's something I did not cover just yet. You can see there we have a current instance count and a desired instance count. I will get back to that later. This is an interesting thing that you can do with SageMaker as well. So from there, we could actually invoke the model. So that model is running already. That endpoint is running already, so I can actually invoke it right away. So if I was to call that specific block there, this is the way you will invoke the model. So as you can see, there will be two things happening. There is that file there, which will be uploaded onto S3. If you remember a few minutes ago, I explained that the asynchronous endpoint will be reading the data from S3 as an input for the machine learning algorithm, the inference algorithm. In that case, since we are actually going to fetch the data from Healthlake Imaging, we don't have to copy the entire DICOM dataset onto the S3 bucket. Instead, we'll be just copying that little file there. And what that file contains is the ID of the data store. So this is the data store in Healthlake Imaging. And then the ID of the dataset. So in Healthlake Imaging, every time you import a DICOM study or dataset, it gets attributed an image set ID. That image set ID is an identifier that you use to get access to the pixel data or to the metadata. So with these two information only, it should be sufficient for the map to be able to go fetch the data from Healthlake Imaging and run the inferencing on the data. And then once I have copied that data onto the S3 bucket, I can actually invoke the endpoint itself. And then it's asynchronous. It's going to take a bit of time to process the prediction results. But after a few seconds, the prediction result will be output on that location. And then from there, I will be able to go fetch the data. I can do it manually, like I can go on the S3 bucket and go look at the data myself. Or I can actually download the file onto my consuming application and then do whatever I need with that prediction result. So let's see if that one is actually finished already. Yeah, it seems like. So now the file is downloaded locally onto our notebook environment. Then I can try to display that file, which is the segmentation for the spleen. And yes, so we have our segmentation result there. So let me get back to the fact of that endpoint, which was configured for one current instance and then a certain amount of desired instance count as well. This has to do with the auto-scaling feature of SageMaker. So SageMaker has that ability to make sure that you are only going to consume the amount of resources you need at a certain point of time, right? So when you configure that specific endpoint, you could say, I want to make sure that I have always one instance running because I cannot tell when people is going to hit that endpoint. But maybe during the day, I will need maybe more than that because I know that my general resource consumption is more about using 3 or 4 instances at one time. So I can put my maximum cap at 4. And then the auto-scaling feature of SageMaker will actually take care of monitoring the amount of resource usage and spin up these instances at its need in real time. And when it's not needed anymore, then it will simply decommission them in real time as well. So these are useful links for you to try. So this is the Healthlake Imaging preview sign-up, as I explained already. Healthlake Imaging is not enabled by default on all AWS accounts. So you will have to use that link to go request the enablement of Healthlake Imaging on your account if you want to try out. There is a little delay in